Next, we're going to look at quadratic functions. You may be asked to find a lot of things about a quadratic function, so we really want to talk through this. We're going to need to be able to graph it, interpret the graph, all of these wonderful things. Now, some of the features that we can look at. One I'm going to tell you that's really easy to find is our Y-intercept. And then if we can factor this, we can find our X-intercepts really fast as well. So let's talk through, how do you find a Y-intercept of any function? So let's talk through it. Y-intercepts. Y-intercepts, you let x be 0. So y equals 0 squared minus 2 times 0 minus 3. What's neat about quadratics, well, actually any function, whenever you see a term with the x's, you can almost cover it up. There's your y-intercept. Now let's look at the x-intercepts. See if we can find them, because I want to graph this and find out everything I want to know. Now, x-intercept. To find this, we are going to try to factor. Or in IB world, they might call it factorize. It just means to factor. So, and we're going to let y be 0. So this is going to be 0 equals x squared minus 2x minus 3. Let's factor this and see what we get. Now remember, when you factor, x times x gives me x squared. What multiplies to be negative 3 and adds to be negative 2? Well, that's negative 3 and a positive 1. Now, for those of you who remember, you're going to set each of these equal to 0 and solve. Or it's really easy. You're going to have an x-intercept at 3 and negative 1. The x-intercepts will be 3 and negative 1. Because x minus 3 to equal 0, it's going to be 3 and negative 1. Now I'm ready to start graphing this. One, two, three, four, five. 1, 2, 3, 4. 1, 2, 3, 4. I guess I made it a little bit too big. That's okay. It happens, right? So the y-intercept is negative 3. X-intercepts are at negative 1 and 3. Now, other things we might want to find are vertex. So let's talk about the vertex. And there's a couple of ways to find the vertex. Now, the vertex, remember, that's the turning around point of a quadratic function. One way to find the vertex is to use, there's a little formula to find the x-intercept of the vertex. That formula will be on your formula chart. It's negative b over 2a. Let's first find it using this formula. So negative b was already negative, so we're going to have to make that positive. And 2 times a is 1. So this is going to be negative 2 divided by 2, which is 1. Now all we have to do is plug that in to find the y value that goes with it. So that would be 1 squared minus 2 times 1 minus 3. And you'll notice I show when I plug into things. IB really likes you to do that. So 1 minus 2, that's negative 1, minus 3, that's going to be a negative 4. So my vertex is at 1, negative 4. Now I said there was more than one way to find the vertex. The other way is to know that your vertex isn't going to be closer to one side than the other. It has got to be exactly between your x-intercepts. If I had averaged, oops, well, that's close enough, the x-intercepts, 3 plus negative 1 divided by 2. That's 2 divided by 2, that's 1. I would still have come up with the same x-coordinate. So if you know your x-intercepts, that is a really fast way to find your vertex. Now if you don't, negative b over 2a is not hard. So either way is going to get you there. Now let's graph our vertex. It's at 1, negative 4. Here it is. So now we can make a nice sketch. Now the reason I say sketch is because I'm not putting every point exactly where it is. But we do know that if this one's here, then there's going to be another one just opposite from it. Now how do I know that? Well, you can also say I've been doing this a long time. But the other thing I know is that whenever you have a quadratic, you have symmetry. And this dotted line, this is the axis of symmetry. It always goes straight through that vertex. It makes it equal on either side. Now that axis of symmetry is the line x equals 1. You'll notice that it's the x value of our vertex.